Hello, this is Mr. Miller and welcome to video 5G, more about increasing and decreasing functions. We're going to do several examples where we're to find the critical points of a function and identify the intervals where the functions are increasing and decreasing and locate any relative maximum or minimum. Here we go. We're going to start with a visual example. We have a graph, so that makes things a little easier. The first instruction is to find the critical points. Well, critical points are points where the derivative is 0 or undefined. So we see this is a place right here where f prime is 0, it has a horizontal tangent. There's a critical point here. That sharp corner is a point where the derivative is undefined. And there's another sharp corner here. So we see that there are 3 critical points for this function. Okay, we want to identify the intervals where it's increasing or decreasing. Well, it's decreasing right here, this part of the graph, until it gets to that first critical point. This is a point, or this is a part of the graph where the first derivative is negative. Decreasing there. F prime is negative. The slope of the curve is downward. Then, after this critical point to this little maximum here, the derivative is positive. So it's increasing there. And then on the other side of the maximum, the function is going down again. The first derivative is negative, so it'd be decreasing there. And then to the right of this critical point here, it's increasing. The derivative would be positive there. So that was a visual example here, just to give you an idea of what we're looking for. And notice the critical points are places where it can change from increasing to decreasing. Right here, it was going down, and at this critical point, it changes. It changes at this critical point, and it changes at that one also. Now, those are places where it can change. It may not, but it can change there. All right, let's do our first solid example here. So here, no graphs. We're given a function f of x here, and we want to find the intervals where it's increasing or decreasing. So the first thing we're going to do is find the critical points. So we're going to take the derivative and we're going to set it equal to 0. So f prime of x would be minus 3x squared plus 18x minus 24. And we want to set that equal to 0. We're looking for places where the tangent line is horizontal. Now, I can make this a little bit easier to solve by dividing everything by negative 3. I get x squared minus 6x plus 8 equals 0. And we can factor this. If we're having trouble factoring it, we can always use the quadratic formula to solve it. We get x equals 2 and 4. Those are our critical points. So 2 and 4. There are no points where the derivative is undefined, so those are only 2 points we have to worry about. Okay, and it divides the number line up into 3 pieces. Now, we just got to test these intervals. We're going to pick a point in each of these 3 intervals and substitute it in the first derivative and see what we get. So I'm going to pick negative 3. I'm sorry, I'm going to pick 0. So f prime at 0, that's a point in this far left interval. If you put that in the derivative, you get negative 24. I'm substituting it into the derivative right here. That's a negative number, so we know the function is decreasing on that interval. So I'm going to draw a downward arrow. Then I'm going to test a point in here. I picked x equals 3. So f prime of 3, if you put that in, is equal to 3. So the derivative is positive, so the function's increasing there. And for the last interval, I picked 5. And f prime of 5 is negative 9, which means the function is decreasing here. So I'm not going to write the intervals out, but we got 2 intervals where the function's decreasing, 1 interval where it's increasing. Now, right here, the function is going down, then it turns around and goes up. Kind of looks like that would be a minimum. So x equals 2 is a relative minimum. And right here, the function is going up, then it turns around and goes down. That must look like that. That is a relative maximum. Okay, we finished our job. First example done. Okay, let's move on to this one. This is one with a fractional exponent. So, same thing. We got to find the critical numbers. So we're going to take the derivative, and we get f prime of x equals 2/3 3x plus 9. I'm going to subtract 1 from the exponent, so that'd be to the minus 1/3, times the derivative of the inside. That's the power rule, so times 3. 2/3 times 3 is 2. And we can put this in the denominator as the cube root of 3x plus 9. And so that's f prime of x. Now, if we set it equal to 0, this is actually never equal to 0, because the numerator is never equal to 0. However, there is a point that makes the denominator 0, and that would be where the derivative is undefined. So that counts as a critical point. The function is defined, but the derivative is not there. Okay, so we got to test two intervals. So I picked -4 and 0. So if we do f prime of -4, we're substituting it into this mess right here. You end up getting 2 over the cube root of -3, which is about -1.387, which means the function's decreasing there, right? Going down. And then I substituted 0. I get f prime of 0 is 2 over the cube root of 9. I don't really need to know the decimal. Both of those are positive, so this is greater than 0. Function's increasing. And we see that -3 must be a minimum. Okay, we're half done. All right, this is a rational function, and we need the quotient rule to find the derivative. We've practiced the quotient rule a lot, so I'm just going to kind of write the derivative here. You could also check it with your calculator. So we get f prime of x equals, well, in the numerator, we get 3x squared minus 6x. And in the denominator, you would get 3x minus 3 squared. Okay, and we want to set this equal to 0. So we have a fraction, we want it equal to 0. All we have to do is set the numerator equal to 0. And if I factor out a 3x, we get 3x times x minus 2 is 0. And we get x equals 0 or 2. So those are critical points. But that's not the only place where the function can change directions. There's also a discontinuity in this graph. This function is undefined at x equals 1. If we put 1 into the denominator, we get 3 minus 3, which is 0, which means there's a vertical asymptote there. So at 1, there's a vertical asymptote, and that creates another point where the function can change directions. So we actually have 4 intervals to test. Okay, and we got to put them all in this function. Now the way I did it is I just entered that into my graphing calculator and used the table feature. Made it really easy. So I'm going to test -1, which is in this interval. Okay, and I got 1/4, which is greater than 0, so that's increasing. I put in 0.5, or actually -0.5, and I got -1. The function's decreasing. I put in 0.5 and I got -1 again, which means the function's decreasing here. And finally, I put in 3, which gave me 0.25. The function's increasing. Okay, so 2 intervals where it's increasing, 2 intervals where it's decreasing. And we see that x equals 0 is a relative max. And x equals 2 is a relative min. 1, the function is not even defined there, so it can't be a max or min. Alright, time for the last example. So each function is kind of different kind of function this time. In this example, we have a trig function. Okay, so we're going to take the derivative. Actually, the derivative is not bad to take at all. We get f prime of x equals, well, the derivative of cosine is minus the sine, so it'd be minus the sine of 2x, times the derivative of the inner function, which is 2. So we get f prime of x equals minus 2 sine of 2x. We want to set it equal to 0. Now, we can use the unit circle to solve this actually, and we're interested in solutions in between negative pi and pi, but we've been kind of using our calculator lately to do this for us. And recall, a calculator gives us something a little bit strange. My calculator gave me x equals, and it has this a symbol, n15 pi over 2. Remember, this mess right here, you should just think of as n. So it's multiples of pi over 2 for n equals 0, plus or minus 1, plus or minus 2, etc. So what you do is you put in values of n, and we try to find all the values that are in the interval we want. So if we put in n equals 0, 0 times pi over 2 is 0. If we put in n equals 1, 1 times pi over 2 is pi over 2. If we put in negative 1, we get negative pi over 2. So far, these three numbers are inside the interval. Now, if I put in 2, I get 2 pi over 2, but that reduces to pi, which is actually the endpoint. I'm interested in critical points on the end side. And similarly, if you put in negative 2, you get negative 2 pi over 2, which is negative pi. So we really don't want those. The critical ones are the ones inside the interval, and it would be those numbers. So we have 0. We have negative pi over 2, and we have pi over 2. This problem is kind of weird because we want to make sure we stay within the interval we're given. So I'm going to mark the interval we're given. So we have 1, 2, 3, 4 little intervals to consider. Alright, it helps maybe to find the decimal. This is minus 1.57. Pi is like negative 3.14. This would be 1.57 and positive 3.14. That helps me pick some decimals to put in. So I substituted negative 1.6 for this interval. And I got negative 0.117, which means it's decreasing here. Then I put in f prime at negative 0.5. And I got positive 1.683, which means it's increasing here. Then I put in 0.5. And I got negative 1.683, which means it's decreasing. And then I put in, finally, 1.6. And I got 0.1187, which means it's increasing here. Okay. So, yeah, that looks right. All right, so those are the intervals. It's decreasing, increasing, decreasing, increasing. X equals negative pi over 2 is a relative max. So, or sorry, minimum. There's a relative min right here. And this point right here, at 0 must be a relative max. And this point here is decreasing and increasing. That's a relative min. Alright, what a mess. But it's kind of cool. We can handle trig functions, especially if we know what our calculator is telling us when we use the solve button. Okay, wow. Now, I have two examples for you for the journal assignment. You can use your calculator to find derivatives and certainly to evaluate them if that helps you. First one's a cubic function. The second one is a rational function. Find the critical numbers. Remember, for part B here, you also have to include where the vertical asymptote is. And find the intervals where the function's increasing or decreasing. And let me know if there's any relative maximum or minimum. Okay, you can do it. Good luck.